This video is about applying properties of parallelograms and determining if a quadrilateral is a parallelogram based on a set of conditions. So there are 6 conditions to know if we have a parallelogram. The first is if both pairs of opposite sides are parallel. So that comes from our definition. So the opposite sides have to be parallel, so top and bottom and left and right. The second condition is if one pair of opposite sides are both parallel and congruent. So let's, for example, say the top and bottom are parallel and they are marked congruent. We could also have the other way where the left and right sides are parallel and congruent. So it just depends on the problem. Both are possible. Our third condition is that both pairs of opposite sides are congruent. This comes from a property of a parallelogram, so the top and bottom are congruent, the left and right are congruent. We also have conditions dealing with angles. So that first condition then is that if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So B and D are across from each other, they are opposite angles, and A and C would have to be congruent. Our fifth condition, if an angle of a quadrilateral is supplementary to both consecutive angles, then it's a parallelogram. So remember that supplementary means that they have to equal 180 degrees, and consecutive means they're angles next to each other. So for example, if we know that angle D is 110 degrees, we would need A and C to be 70. So when I add these two together, I get 180 degrees. And when I add these two together, I get 180 degrees. So they are both supplementary to both consecutive angles. Our last condition then is if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So when we draw in our diagonals need to cut each other in half. Now they're not going to cut them into congruent equal parts, they're just going to cut them in half. But remember that we are going to have one diagonal shorter than the other diagonal, so not all 4 pieces will be congruent, just the pieces on the same diagonal. So let's look at some problems and figure out, based on the information, do we know if they are a parallelogram? So in number 1 right now, we have that BC is congruent to AD. We also have these angles that are supplementary. So because those angles are supplementary and they are same side interior angles, that would also make these lines parallel. So we have a set of opposite sides that is both parallel and congruent. So this would be a p-gram or a parallelogram, a way to just shorten that, because one set of opposite sides is both parallel and congruent. In number 2, we have that B and D are congruent angles and A and C are congruent angles. So again, this is a parallelogram because 2 sets of opposite angles are congruent. In number 3, we have 2 angles that are 57. They are opposite angles and they are congruent, but 123 and 120 are not congruent. So we only have one set of congruent angles, so this is not a parallelogram because only one set of opposite angles is congruent, not both. In number 4, we have that BE C is parallel to AD, and we have that the other two sides are congruent. But it's not on the same set of sides, so this would not be a parallelogram. So this is not a parallelogram because the same set of sides is not both parallel and congruent. In number 5, we have BC is congruent to AD, but we don't have anything else. So we would need a second side. So this is not a parallelogram because only one set of sides is congruent. In number 6, we have one diagonal that's bisected. We don't know about the other, so we can't say this is a parallelogram. This is not a parallelogram because only one set of the diagonals is bisected. In number 7 now, we have both diagonals are bisected, so this would be a parallelogram because the diagonals bisect each other. In number 8, we have one angle D. If we look at these two angles, that equals 180 degrees. These also equal 180 degrees, so this would be a parallelogram because one angle is supplementary to both consecutive angles. In number 9, we have the sides that are parallel because they both have two arrows, and they are congruent because they both have the same marking, so this is a parallelogram because one set of sides is both parallel and congruent. So as a review, remember the properties of a parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So let's look at some more practice problems with parallelograms. Based on the information, what else is needed to prove DELZ is a parallelogram? So right now we know that angle E is congruent to angle Z. So that is one set of opposite angles congruent. We need a second set of opposite angles congruent. So we would say angle D needs to be congruent to angle L. In number 2, we are given that DE is congruent to ZL. So there are two choices we could make to have it be a parallelogram. We could have two sets of congruent sides. So we would need DZ to be congruent to EL. Or, sticking with the same set of sides, we could have those also be parallel to each other. So we already know they're congruent. We could also say that DE has to be parallel to ZL. In number 3, based on the diagram, is the quadrilateral a parallelogram? So in number 3, we only have one set of congruent angles and we need two. So is this a parallelogram? No, because only one set of opposite angles is congruent. In number 4, we have that the top and bottom sides are congruent and the left and right sides are congruent, that gives us two sets of opposite sides congruent. So this is a parallelogram because two sets of opposite sides. It's very important that we include opposite in this. Two sets of opposite sides are congruent. In number 4 and 5, we want to draw and label the parallelogram, and then we want to solve for x. So in number 5, when I draw my parallelogram, I want to make sure it doesn't matter where I start, but I go in a circular motion to label the rest of my letters. So I'm going to say P, A, R, T. Angle P is 7x minus 10, and angle T is 2x plus 10. So if we are solving for y, solving for x, these angles are consecutive angles, so together they have to equal 180. So we have 7x minus 10 plus 2x plus 10 equals 180. Gets us 9x equals 180, so x is 20. In number 6, again, we want to label our parallelogram in a circular motion. We cannot skip. We can't go like C-O-N-E. That's not correctly naming it. Okay, we have to go in order. So C-O-N-E. Okay, I always just go clockwise. You can also go counterclockwise. It doesn't matter. So we know that CO is 2x plus 7. ON is 3x minus 1, and NE is 23. So we know that opposite sides have to be congruent. So the two opposite sides that have information are 2x plus 7 and 23. So those have to be equal to each other. So 2x equals 16, x is 8. In the rest of these problems, we want to look at the diagram and figure out why we know it's a parallelogram and then solve for x. So right now, if I look at the picture and I ignore the variables, I see two sets of angles are congruent. So we know this is a parallelogram because two sets of opposite angles are congruent. Now that we know it's a parallelogram, we can use our other properties. So we know if it's a parallelogram that our opposite sides have to be congruent. So in this case, the two sides that are across from each other that would be congruent are x squared plus 3x and negative 5x plus 20. So we're going to move everything to the x squared side. X squared plus 8x minus 20 is equal to 0. We need two numbers that multiply to negative 20 and add to 8. We get x plus 10 and x minus 2 is equal to 0. Switch our signs, so x is negative 10 and x is positive 2. In number 8, when I look at my diagram, I see that the opposite sides on the top and bottom are congruent and they are parallel. So we know this is a parallelogram because one set of opposite sides is both parallel and congruent. So now we're going to solve for x and y. So if I look at the two angles that have x, they are consecutive angles, so they have to be supplementary. So 6x plus 51 plus 4x plus 19 has to equal 180. So we get 10x plus 70 is equal to 180. 10x equals 110. So x is 11. Now that I know x is 11, I can substitute in to get one of my angles. So I'm going to do 6 times 11 plus 51. That gets me 117 degrees. So I know my opposite angle also has to be 117 degrees. So I have 7y plus 61 is equal to 117. We can subtract 61 from both sides. 7y equals 56. So y is 8. In number 9, we see that the diagonals are bisecting each other, so that means that we have a parallelogram. So we know this is a parallelogram because both diagonals bisect each other. So we know that the opposite sides have to be congruent. So 4.5x minus 18 has to equal 2.2x plus 9.6. So we get 2.3x is equal to 27.6. We can divide by 2.3, so x is 12. So let's look at one more problem here. So in here, we have some sides labeled. We also have angle measures. If I look closely at these angle measures, I know that these two together equal 180, and these two together equal 180. So we know this is a parallelogram because one angle is supplementary. That's why it equals 180 degrees to both consecutive angles. So now we can solve for x and y. So we know our opposite sides are congruent. So we have 3x plus 6y is equal to 42, and 4x minus y is equal to 11. So we know this is a system because we have x and y's in both equations. So in the second equation, I'm going to multiply by 6. 3x plus 6y is equal to 42. 24x minus 6y is equal to 66. So we add straight down, we get 27x is equal to 108. And when we divide, we get x is 4. Then we're going to go back and substitute to solve for y. So we have 4 times 4 minus y equals 11. 16 minus y equals 11. So negative y equals negative 5. Y is positive 5. So we have 4, 5.